So basically we are going to cover the topic Jacobian in this short demo class. So Jacobian is basically a method used for solving complex equations or complex variabled equations easily. So basically in a Jacobian equation you'll be given three variables which further would be in terms of variable. So for example, you're given, let's say, a variable u which is some value of x, y and z, a variable v which is again an equation consisting of x, y and z, and a variable w which is again an equation, a complex equation consisting of x, y and z. So they'll ask you to differentiate u, v and w with respect to x, y and z. So we call this differentiation as Jacobian. So basically when they say partially find the derivative, partial derivative of u, v and w with respect to x, y and z, wherein u, v and w are nothing but some equations of x, y, z only, you call this thing as J, which is Jacobian. So let me try and explain you this with a simple example. So let's say we have u. So it's a very general question usually asked in exams. So let's say we have u as x square, y square and z square. Okay, we have v as xy plus yz plus zx, that is xz, and we have w which is x plus y plus z. So now the question is, they would say find u, v, w by x, y, z. So basically they are saying find partial derivative of u, v, w in terms of x, y, z, or they could simply ask you, the question can be find Jacobian of u, v and w in terms of with respect to x, y and z. So one and the same thing. So basically this thing is called a Jacobian. So we can also denote it as J. So basically they're asking us to find a Jacobian of u, v and w. So a simple rule to find Jacobian is, so whenever you want to find Jacobian of u, v and w in terms of x, y and z. Now remember these are just variables. These could be any variables and also these could be any variables, but the upper variables will always be equations consisting of the lower variables. So when they ask you to find Jacobian of u, v and w in terms of x, y and z, so let's say this is the question. So very simple rule is, Jacobian is a determinant of, so what we do is, so there is a determinant matrix, we write it as, this is a very simple thing. So basically these variables u, v and w. So let's take the first variable which is u. So derivative of u, partial derivative of u with respect to x, partial derivative of u with respect to y, and partial derivative of u with respect to z. The next row would consist of partial derivative of v with respect to x, dou v, dou y, dou v by dou z. Again the next row would contain w, dou w by dou x, that is partial derivative of w by with respect to y, partial derivative of w with respect to x, and partial derivative of w with respect to z. So now this entire thing is basically Jacobian. And how to solve this thing? So now you will be calculating each and every value and putting it here in a matrix and finding the determinant of that matrix. That will be the Jacobian value. So let's find it out one by one. So it's partial derivative of u with respect to x. Now look at u. So this is u. So when they say partially derivated with respect to x, it means x is the only variable, rest any other variable apart from x will be considered as a constant. So when you partially derivate it, you will only derivate this term, you'll only derive this term. So the answer would be du by dx, dou u by dou x would become, it would become 2x, right? Similarly, dou u by dou y, dou u, this u, you have to you have to take differentiation of it with respect to y. So this would become, this would be a constant term 0, this would be a constant term, this would become 2y. In case you do not know how to differentiate terms, how to do partial differentiation, that will be a separate class, but for the demo purpose, I'll be just explaining you how to take out the Jacobian. Then again, dou u by dou z. So basically now differentiating it with respect to z. So these two terms become 0 and the answer becomes 2z. Okay. Now, dou v with respect to dou x, v with respect to x. So if you see this, y becomes a constant here and x differentiation would be 1. So basically it comes out to be y plus, here also we have an x term z, dou v by dou y. So if we differentiate this thing with respect to y, this will be x plus z, plus z, and this term would be 0. And if we differentiate v with respect to z now, this would be y plus x. Okay, y plus x. Similarly, differentiating w with respect to x first. So if you differentiate w with respect to x, it would be 1 only, because this will become 1, 0, 0, because these terms would be considered as constant. Now differentiating w with respect to y, so x would be constant 0, this term, differentiation of this term would be 0, plus differentiation of this thing would be 1, and differentiation of z would again be 0. So 0 plus 1 plus 1 would be 1. Again differentiating this thing, partial derivative of w with respect to z. So I hope you understand partial derivative of w, which is, it goes like this. So w is x plus y plus z, and when I say partial derivative of w with respect to z, that means that you only have to consider z as a variable, rest other variables would be constant. So that means dx by dz, dy by dz plus dz by dz. Now these things x and y are constant, so differentiation of constants would be 0 plus 0, and this would be 1. So that's how the answer is 1 in all these cases. So this is also 1. Okay, after this step, what we do is, so the process is not yet over. What we do is we now find the determinant. Now there was a rule of finding the determinant, if you remember, in we have studied that in our 12th class. NCERT teaches it, but anyways, the rule was that you take the first term. Okay, so we will just be taking the first row, or any row for that matter, but we'll be considering the first row. So take the first term, which is 2x. So I'm writing it here, 2x bracket. Now what you do is you cross this row and you cross this column and you cross this row. So whatever is left, you cross multiply them. So basically hiding this thing and this thing. So x plus z into 1 minus y plus x into 1. So that is the rule. So basically cancelling this thing and this thing, you'd be left with this thing. So x plus z into 1, x plus z into 1 is x plus z only, minus y plus x into 1. Okay, now this was the first term, so we close the bracket. Now coming to second term, this would be minus 2y Now the rule is cancel this row or this column and this row. So basically what is left is, and if you cancel this, so it's x plus y plus z into 1, which is y plus z only, minus y plus x into 1. We cancel this and this, so y plus z into 1 and y plus x into 1, which is y plus x only. Now third thing would be plus 2z. So I hope you know this. This term, then cross multiplication of this term, minus second term, then cross multiplication of these, and plus third term, cross multiplication of these. And now if we cross multiply, so when I'm cancelling this column and this row, it would be y plus z into 1 minus x plus z into 1. So the third term was 2z. Okay, I'm writing it here. 2z, this would be plus 2z. Y plus z minus x plus z. Now if you open up all the brackets, so this would be 2x plus z minus y minus x cancels out x, this would be z minus y, minus 2y, okay, minus 2y, y plus z minus y minus x, minus cancels out, so this would be z minus x, plus the third term, which is 2z, y plus z minus x minus z, plus z minus z cancels out. Now this would be y minus x. Okay, taking 2 common and opening up all the terms, I get, so this would be xz minus xy minus yz minus plus y x minus yz plus yx plus zy minus zx. Okay, so expanding these terms, all the terms get cancelled and the answer comes out to be 0. So Jacobian here would be 0. Now let's do another question, which should be a bit complex one. So let's say this time, so the question is, if u is equal to so if u is equal to yz by x, v is equal to xz by y, and w is equal to xy by z, then find Jacobian of or partial derivative of uvw with respect to xyz. And they may also ask you to find Jacobian of uvw with respect to xyz, or in other words, what they do is they would give you an answer. They would say, show that this thing is equal to that answer. So basically you just have to take out Jacobian only. So let's apply that method again. So I told you Jacobian is equal to right, and we say this is the determinant dou u by dou y dou u by dou z dou v by dou x dou v by dou y dou v by dou z dou w by dou x dou w by dou y dou w by dou z. So let's take it out one by one. Dou u by dou x, that means differentiation of u with respect to x. So basically yz would be constant, they would come out, and differentiation of 1 by x would be minus of 1 by x square. So this terms comes out to be yz minus yz by x square. Differentiating u with respect to y, this would be z by x. Differentiating u with respect to z would be y by x. Similarly, if you differentiate v with respect to x, this would be z by y would be constant, and differentiation of x would be 1. So this would be z by y. Okay, so I am pronouncing it z and z alternatively, I don't know, but it's just my way of pronouncing this word. So you call it z, you call it z, doesn't matter. Okay, differentiating v with respect to y, so this would be x z would be constant, it would come out, and differentiation of 1 by y with respect to y would be minus 1 by y square. So this term would become, actually this term would become minus right. Now differentiating v with respect to z, this would be x by y. Similarly, the third row would become, I would suggest you to note down the value of u, v and w somewhere in your rough register and start doing the question with me so that you better gain interest in it. Again, differentiating w with respect to x. So where is our w? W is x y by z. Differentiating this with respect to x would become y by z. Differentiating it with respect to y becomes x by z. Differentiating this term with respect to z becomes xy constant, and 1 by z becomes minus, so basically xy constant and minus, and each this would be z square. Okay, so this is the matrix that we have obtained. Now finding the determinant. So the simple rule would be, first term, which is minus yz by x square, and inside the bracket we would cancel first column and first row. So this term into this term minus this term into this term. So this term into this term comes out to be minus minus gets cancelled, so it comes out to be x square zy, and okay, yeah, y. So if you multiply this, so one y gets cancelled and one z also gets cancelled, so this becomes x square by yz, right? X square, z and y, z and y gets cancelled, so this becomes x square yz. This is minus this into this, which is x square by yc. So good news, this becomes 0, so this entire terms would be becoming 0. Minus of second term, which is z by x, and now cancelling this and this, so zy, this term into this term. So when you multiply this term with this term, this is minus, z gets cancelled, 1y gets cancelled, so basically this becomes x upon z, right? Now the next term would be this into this, which is minus y, and y gets cancelled, minus x by z, plus third term is y by x, cancel this and this, so you will have to multiply this with this. So z gets cancelled. If you multiply z by y into x by z, z gets cancelled, so this would be x by y minus this term, these terms. So just see it carefully, minus x z by y square, minus x z by y square into y by z. Oh sorry, z gets cancelled, 1y gets cancelled, so this would be minus x by y, but there's already a minus, so this would become plus x by y. So now this becomes 0, so this entire terms becomes 0, minus x by z, this would be z by x into 2x by z, which is minus 2x by z, plus y by x into 2x by y. So when we open this out, minus would get cancelled, these are getting multiplied, so z gets cancelled, x gets cancelled, this would be 2 plus y gets cancelled, x gets cancelled, 2, 4. So the answer is 4. So Jacobian for this equation would be 4. So I hope you understood the concept of Jacobian and how to calculate it. In case there is any other doubt, you can follow the next session. Thank you.